All right, so this is the Honors Chem screencast for objective number 6, distinguish between physical and chemical changes. We've already started talking about physical properties, so hopefully some of this stuff will make a little bit more sense to you today. So in a physical change, it's an alteration of the material that does not change the composition, meaning we're not making anything new. We're just going to change the appearance or chemical state. Examples would be boiling, freezing, or melting, condensing, any of those state changes. Anytime I change from a solid to a liquid or a liquid to a gas, I'm not making anything new. I still have that substance. I'm just changing its state. If I break something in half, if I split something in half, I take a rock and I break it in half, I still have the same rock. I haven't made anything new. Cracking something, like if I crack a sunflower seed open, I still have the sunflower seed. Grinding, cutting, or crushing. So those are all examples of physical changes. Most of the time we think of physical changes as reversible. If I break a rock in half, I'm not going to be able to put it back together, but theoretically I should be able to put it back together. But if I boil water, I can just, like here, if I boil water to create steam, I can cool that water down to get it back into a liquid again. So physical changes, some examples. Mixtures can be separated into substances through physical changes. That's how you can identify that something is a mixture. If I can separate it out without doing anything fancy or doing a chemical reaction, it's a mixture. So physical changes can be reversed and do not alter the composition of the substance. Iron and sulfur, for example. If I put iron and sulfur and I mix those two together, there's a property that iron has that sulfur doesn't. Iron's magnetic, so I can use a magnet to separate them back out. Salt dissolved in water. If I put salt, dissolve it in water, and then I boil the water off, I'm going to have the salt left over. Oil and water, the oil floats on top of the water, so I can just skim it off the top because they separate. So those are all mixtures because I can physically separate them. Some examples of physical separation include distillation, crystallization. So distillation is when you purify a liquid, like distilled water. Crystallization, you allow something to solidify, and then you can just pull out the solid pieces. You can separate them by density, like the oil and the water. I can use a magnet, like with the iron and the sulfur mixture. I can filter something out, like if I had sand in water, I could just filter out the water. Decantation is a specific type of filtering where you just rinse something a couple of different times. And we'll go over these again in class as we watch these videos on how to separate mixtures and how to do, or how crude oil is made through the process of distillation, but it's fractional distillation. So we will watch some video clips on how to separate mixtures. You will do a couple of different labs where we will separate or we're going to do a physical and chemical changes lab, but we're also going to do a mixtures lab where we will distill cherry Coke. And then we're going to separate sand, salt, and iron. So there are 3 different labs that we are going to do with physical changes, as well as chemical changes. So some properties of matter, the chemical properties is the ability of the substance to undergo a chemical reaction to form a new substance. So when you do a chemical reaction, you're forming something new. That is a chemical change. It is not something where you just mix these things together so I can unmix them. I am forming a whole new material that I can write a formula for. Examples of words that indicate a chemical change would be burn, cook, rot, rust, decompose, ferment, grow, sprout. Once something burns, you can't unburn it. Once you bake a cake, you can't unbake the cake. Once something grows, you can't ungrow again. So elements can be combined to form compounds based on their chemical reactivity. Most of the elements on the periodic table will react. The noble gases will not, which is why they're called the noble gases, the very last column on the periodic table. That is their chemical property. They don't react. So in a chemical change, new properties are seen within the substance that is formed by a chemical change. So I make something totally new that's now going to have new physical and chemical properties. The appearance and the behavior is different. That's what we mean. The physical appearance is different, and the behavior, the chemical appearance or the chemical behavior is very different from the original substances. A chemical change is not easily reversed. Like in those videos that I showed you where they mixed sugar and acid together and made the black snake, I'm not going to be able to reverse that without doing another chemical reaction. If I burn paper and get the carbon out of it, that is actually not reversible. I can't unburn the paper once I've broken down those chemical bonds. So those are examples of chemical changes. Evidence that a chemical change is happening You might see a color change, like bread dough baking goes from white to brown. There might be a smell change, like eggs rotting or when food goes bad. They don't smell good. The new matter is created, so when wood is burning, it changes to ash, so I've made something new, just like the paper burning. Gas being created. If you have bubbles coming off of something, you might get carbon dioxide gas or hydrogen gas or oxygen gas coming off, and you're going to see effervescence, which is bubbling. And then heat or light might be created, such as in a firework. You're going to do a lab where you will burn magnesium and it will give off light. So that tells you that a chemical reaction is happening. Another one is also the formation of a precipitate. Like if I have this liquid that's in the pipette and I add it to this liquid in the test tube and I get this cloudy substance, that's a solid that's coming out of solution. That's a precipitate. So if you get a solid out of solution, that is a precipitate, and that's a sign that a chemical equation or a chemical reaction has happened. So basic chemical equation writing formula, or the way to write the basic chemical equation. Reactants are going to be on one side, the starting stuff. You're always going to have an arrow, and the arrow is going to point to the products. So we've got reactants that we start with, the arrow, and the products that we end with. That means the yield sign. It always points to the products. So you start with reactants, end with products. The plus sign indicates different substances. So I might have this reactant plus this reactant will make this product plus this product. So it just means and. And you can have elements or compounds listed as your reactants and your products. The triangle, a lot of times you might see a triangle over the arrow, and I'll show you what this is in class if you need, or if you want to see an example of it. But that usually means that that reaction requires heat to go. If heat is needed to make it go on the reactant side, it's going to be an endothermic reaction because it has to take in heat energy. But if energy is produced, if it gets hot, that's an exothermic reaction, and you will see it listed on the product side. So we have a video that we're going to watch in class about chemical reactions. If you see an element over the yield sign, that usually tells you that it's a catalyst that's needed. So if you see something that's listed, a lot of times you might see water that is listed. Water is something that makes that reaction go, or it won't go without that. So that's going to be the catalyst that might speed up or slow down a chemical reaction. Okay, so when you get this homework assignment assigned to you, one of the things it's going to say for you to do is to go to these 3 websites and to complete these. They're just little quizzes, little practice problem things. You're only going to have to do 2 out of 3. I don't care if you do 1 and 3, if you do 2 and 3. I really don't care which ones you do, if you do 1 and 2, but you need to complete 2 of them, and then you'll report your score to me, and you will be assigned that on Monday. So don't necessarily worry about that right now. And that is it for objective number 6.